We're going to start working with inverse trig functions today. And we talked about at the end of last class how to graph them. Y equals inverse sine of x, inverse cosine of x, and inverse tangent of x. And so we talked about the domain and the range for inverse sine, inverse cosine, and inverse tangent. We got these by graphing our normal sine curve and then flipping the x and the y coordinates so that we now kind of have a curve on the y-axis. We then restricted its range so that it passes the vertical line test and we have a function. Here's just a brief look at what inverse secant, inverse cosecant, and inverse cotangent look like. You don't really, we don't do too much with them, but if you want to have access to them, there they are. And then a summary of the range or of the domain restrictions for inverse sine of x. Everything is between negative pi over 2 and pi over 2. For cosine of x, it's between 0 and pi. And for tangent, it's between negative pi over 2 and pi over 2. So if there's anything outside of these, it means that we've done something wrong, or we need to find the reference angle that fits in to these areas. So let's take a look at some of these problems. So these are out of order how they are on your sheet. So we're going to do 1, 2, 3, and 4. Okay, and that should be somewhat in the order. The other ones, after doing these, we should be able to do on your own. So this is inverse sine of square root 3 over 2. All right, what in the world is this asking? So as a reminder, inverse sine means we're trying to find an angle. So it's asking, what is the angle? And then sine is opposite over hypotenuse. So what is the angle when the ratio of the opposite side to the hypotenuse is square root 3 over 2? I feel like we're in doubt. So we should probably draw this out. So we have our, x and y axis. I'm going to draw a triangle. We have theta, which we're trying to find. We're trying to find this angle. And we know the opposite side is the square root 3, and the hypotenuse is 2. There's a big hint. Almost everything that we do without a calculator is going to be 30 degrees, 45 degrees, or 60 degrees, or 0 or 90 degrees. So we're going to be using our special right triangles quite a bit. And yeah, this is part of our special right triangles. Oops, trying to change it to red. There we go. So it's 1, this one would be 1, 2, square root 3. 1x, 2x, x root 3. Okay? And so theta is across from the square root 3, which is 60 degrees. So inverse sine of square root 3 over 2 is 60 degrees. Or the answer to the ratio, what is the angle when the ratio of the opposite side to the hypotenuse is square root 3 over 2? This has to be 60 degrees. All right, let's take a look at another one. So inverse cosine of negative square root 3 over 2. We have a negative this time. All right, so this is asking what is the ratio of sides when what is the ratio of sides when the adjacent over the hypotenuse is negative square root 3 over 2? Okay, now the range that cosine can be is between 0 and pi. So when between 0 and pi is cosine negative? Cosine is negative between pi over 2 and pi. So we know that our answer should give us pi over 2 or pi. So somewhere between pi over 2 and pi. So here's my xy axis. I know that it's going to be in the second quadrant because cosine is negative. And so the adjacent side is going to be negative square root 3. and the hypotenuse is 2. Therefore, the opposite side is going to be 1. And it's asking for what is this, let me change the color. What is this angle? Right? So if we have across from the 1 is a 30-degree angle, so the reference angle is 30 degrees, but the whole angle, the angle that we go starting from the initial side and ending on the terminal side, day 1 of unit 5, we would get 180 minus 30, which would be 150 degrees. Okay. Next one, inverse cosine of negative square root 2 over 2. All right, we're in doubt. Even if you're not in doubt, you should probably draw it out. So it's going to be in the second quadrant because cosine is negative. Oop. It's not very accurate drawing, but, you know, c'est la vie. All right, so negative square root 2 over 2. You can do Pythagorean theorem to figure out the third side. I know that the third side is square root 2, but it doesn't really matter. Not going to be able to fit it. That's 2. Okay, square root 2. All right, so we need to find this angle. So this is a 45, 45, 90 triangle. So this one is 45 degrees, or let's do this one in radians. So this is pi over 4. So that means theta, or inverse cosine of negative square root 2 over 2, must be 3 pi over 4. So you might be asking, how did I know to make it 3 pi over 4 as opposed to 135 degrees? I didn't. I just decided this time around. Usually you'll be given, oh, it says radian answers. Ha ha ha. So our answer should have been in radians this whole time. So there you go. There you have it. It should have been in radians. These should have been in radians. We move on. All right. Inverse cosine of 0. Okay, so this is clearly not a special right triangle, but we need to figure out where this is. So when is cosine 0? So cosine is 0 when x is 0 on the unit circle. So that would be here. That would be at the top, right? And so at the top, so this is asking what angle is it when when the when the adjacent side over the hypotenuse is 0. So this would be 90 degrees or pi over 2. So our answer would be pi over 2. All right, so you can do these other ones, these other 5, basically draw it out. Remember, they're asking what is the ratio of sides given this ratio, and then you draw it out and you find what angle should go there. It's either going to be on an axis or it's going to be one of our special right triangles in the fourth, first, or second quadrant. Now let's take a look at some compound inverse functions. And this will be found, if you guys can please go to page 13 of your notes packet. So the first part was on page 12. Now we're moving on to page 13, the third header, and it's called composition of inverse functions. So remember, composition is like a function within a function. So this top says that sine of inverse sine of x equals x for all x in the domain of inverse sine. And it says the same thing for inverse cosine and inverse tangent. Now, when it's not in the domain of inverse sine, inverse cosine, or inverse tangent, you basically are taking a reference angle that would make it to be in the domain of our specific function. Okay, that probably didn't make any sense. So let's try this one. So sine of inverse sine of square root 3 over 2. So let's first start like order of operations. Let's start inside the parentheses. So inverse sine is square root 3 over 2. So boo, boo, boo. Ratio of sides where the opposite is square root 3, the hypotenuse is 2, therefore this side would be 1. So square root 3 over 2. So theta, this theta is going to be 60 degrees or pi over 3. So we have sine of pi over 3 equals, so now we have sine of pi over 3. And sine of pi over 3, so this is now pi over 3, is square root 3 over 2. So you could be saying, Mr. Jameson, it says up here, sine of inverse of sine of x equals x. And square root 3 over 2 is in the domain of sine. Square root 3 over 2 is like when sine is like up here. So it works, right? Yes. But it doesn't always work. So sine, inverse sine of 3 over 2. All right, so let's draw this out. So we have this going on. We have the opposite side is 3. The hypotenuse is 2. Ring, 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 the bell should be going off. Something is wrong. There's no way for the opposite side to be longer than the hypotenuse. So this one has no solution. This one just does not work. Okay? And then let's try this one. Cosine of inverse cosine of square root 3 over 2. So we will do, let's draw this out. So the adjacent side is going to be square root 3. The hypotenuse is going to be 2. And so this theta is going to be pi over 6. So cosine of pi over 6. And cosine of pi over 6 is square root 3 over 2. So because this was in the domain of inverse cosine, this works out very nicely. All right, now the inverse sine is going to be on the outside of the composite function, and the same goes as well. So the inverse sine of sine of x equals x is true for all x in the range of inverse sine, and so on and so forth for cosine and tangent. So inverse sine of pi over 4. So yeah, it's going to equal pi over 4, but let's think this through so that we know what we're talking about. So you start within the parentheses, sine of pi over 4. All right, so when we get sine of pi over 4, we're going to get a ratio of sides. We're going to get a ratio of sides of the opposite of the hypotenuse when we have an angle of pi over 4. So let's draw this out. Boom, boom. Pi over 4 is going to be right here. Boom, boom, boom. Yeah, that's 4. Believe me, 4. And so the ratio of sides is going to be like 1, 1, 1 root 2. Leg, root 2. Right? And then, so the ratio of sides is 1 over root 2, or root 2 over 2, whichever one you want. So inverse sine of 1 over root 2. Yes, I know the root's in the denominator. It doesn't really matter right now because it's going to go away in a second. So what's the ratio? So now it's saying what is the angle when we have the ratio of the opposite of the hypotenuse is 1 over root 2? Well, the angle is pi over 4. Now let's make sure. Oh, I totally forgot to tell you. On this one, you should have changed this one to be cosine. You have sine on that one. So you need to go back, rewatch the video as that. Okay, moving on. Inverse cosine of cosine 2 pi over 3. This is all the way to the right of the same row this is on. All right, so let's start off with cosine of 2 pi over 3. All right, so this is saying what is the ratio of sides of the adjacent over the hypotenuse when we have 2 pi over 3. Okay, so we have an angle of 2 pi over 3. And then I'm going to make my reference triangle, because we're in the second quadrant. All right, so this is going to be pi over 3, or 60 degrees. So that means across from it is square root 3. Here is 1, and here is 2. Special right triangle. So, because this is 2 pi over 3. All right, so, and this is negative 1 because it's going to the left. So cosine, the ratio of sides would be negative 1 over 2. So this is equal to inverse cosine of negative 1 over 2. Now, inverse cosine of negative 1 over 2, so what angle is there, or what theta is there, when the ratio of the adjacent over the hypotenuse is negative 1 over 2? In this case, it's still 2 pi over 3. So at this point, now that we've done like 4 examples, or a few examples where it ends up just being pi over 4, it's nice, it's true. Most of the time it's that way, but not always. So let's take a look at inverse sine of pi over 4. Okay, so sine of pi over 4. So we want to know the ratio of sides when the angle is 5 pi over 4. So I'm going to draw my axes, 5 pi over 4, 2 pi over 4, 4 pi over 4, 5 pi over 4. I'm going to draw my reference triangle. So this reference angle is basically pi over 4. This one is basically our reference angle is equal to pi over 4. So, or like 45-degree angle. So it's like a 45, 45, 90 triangle. So 1, 1, 1 root 2, or leg root 2. All right. So the ratio of sides, and this is negative 1, negative 1. So the ratio of sides is negative 1 over root 2. So inverse sine of negative 1 over root 2. Okay. Now, with negative 1 over root 2, we want to know the angle when the ratio of the opposite over the hypotenuse is negative 1 over root 2. So I'm going to draw another triangle. Now, inverse sine, I need to stay in the domain of inverse sine. So we're in this region. So I'm going to be going, the opposite side is going to be negative 1, and the hypotenuse is going to be square root 2. What's this theta then? So this one is going to be positive 1. The side is going to be positive 1. So if we have 1, negative 1, and square root 2, this looks like an isosceles triangle. So it's a 45, 45, 90 triangle, or pi over 4, pi over 4, pi over 2 triangle. And so this angle is going to be negative pi over 4. So the answer of this ends up being, do it in green, negative pi over 4. So this time, our answer, this number was not in the range of inverse sine, so we couldn't just say that this was going to be 5 pi over 4. We needed to create a second triangle, and that's why we have this step here to make sure that we get this correct. Okay? So let's get a little bit more practice. We're going to do 6 more problems. We're going to go a little bit further down on page number 13. So, yep, keep going down. This is the second to last row. We're going to just get a little bit more practice with our inverse functions and our compound inverse functions. So inverse cosine of negative 1/2. When in doubt, draw it out. So, boom, boom, boom. The adjacent side is going to be negative 1. The hypotenuse is going to be 2. We want to know what theta is. It might be helpful to complete the special right triangle. So across from the square root 3 is the pi over 3, or the 60-degree angle. Therefore, theta must be 2 pi over 3. All right, so inverse tangent of negative root 3 over 3. So it's a lot easier to see it when we convert this to be inverse tangent of negative 1 over root 3. So to, I guess, irrationalize the denominator, going backwards. But when we do this, these negative 1 over root 3 is equal to root 3 over 3. And then when we make the triangle, so tangent, the restricted domain is here. So that means it's going to be negative down here. The opposite side will be negative 1. The adjacent side would be square root 3. And the hypotenuse would be 2. So what is this theta? Is what it's asking. It's across from the 1, which is the pi over 6, but it's going down, so it's negative, so it ends up being negative pi over 6. Negative pi over 6. All right, inverse sine of 1.8. All right, so that means the opposite side is 1.8, and the hypotenuse is 1, like 1.8 over 1. Uh-oh, the opposite side is longer than the hypotenuse. This don't work. All right, and then let's do 3 more. These are with compound inverse functions. So here we have inverse tangent of tan of pi over 6. So we graph pi over 6. So 1, because this is like a 30-degree angle, 1, 2, root 3. We could do, inverse tangent of 1 over root 3. And then what is that angle that's 1 over root 3? Well, it's pi over 6. If you recognize that pi over 6 is in the domain of inverse tangent, you're good. You're good to go. Sorry, if it's in the range of inverse tangent. So inverse sine of sine 3 pi over 4. So let's start with the parentheses, sine of 3 pi over 4. So we have 3 pi over 4. Oops, that's a right triangle there. Getting a little sloppy, I'm sorry. And so if this is 3 pi over 4, this angle would be pi over 4. So that's the same thing as 45 degrees. So it's like 1x, or leg root 2. And so sine of 3 pi over 4 is 1 over root 2. So inverse sine of 1 over root 2. And it's positive because sine is positive in the second quadrant. All right, now we need to make another triangle. See, this one is not in the domain, it's not in the range of inverse sine. So we're going to need to come up, we know that it's not going to be 3 pi over 4. All right, so inverse sine of 1 over root 2. All right, so that means we're now in the first quadrant. The opposite side is 1. This one is square root 2. Okay, the adjacent side is going to be 1. You don't really need this. It just helps us visualize the special right triangle a little bit more. So we have 1, 1, root 2. That's like leg root 2. So this theta must be pi over 4. And then lastly, it gets a little tricky. We don't have the same function for both of these. So we have sine of inverse tangent of negative 1. Okay, so tangent being negative 1. So that means sine and cosine are the same thing, but one of them is negative. So where could that possibly be? Well, maybe here, where the opposite side is negative 1, the adjacent side is 1, and the hypotenuse would be square root 2. So then what is this theta? This theta is, So, because this is asking what is the angle when tangent is -1? And the angle would be negative pi over 4. So we have sine of negative pi over 4. So we can still use this same scenario, but sine is going to be opposite over hypotenuse, -1 over root 2. So our answer would be -1 over root 2, which is equal to negative root 2 over 2. Since it's an answer, it's nice to have the denominator rationalized. Okay? And then with that, you should be able to do the rest of page 13. And then in total, when you come back to class on Tuesday, your homework packet should be complete, pages 1 through 6. And you're more than capable of doing page 7 as well. Page 7 should be done by next Thursday. Math Excel 6.1 A and B, 6.2 A and B, and 6.3 should definitely be completed by Sunday, but definitely by Tuesday. And then you could also be doing Math Excel 6.4. And then in your homework, in your notes packet, pages 1 through 13 should be completed. Not every single part, because we skipped some problems, but the problems that we did in class should be written down in your notes. So if 100% of this is done, then you'll get 100% on the check tomorrow, on Tuesday. And for every part that is missing, you will be docked a point. So it's a 10-point assignment. So if you do pages like 1 through 5, you'll get -1 for that. And if you weren't here for a day, then please either look on the slides on Schoology or watch some of Miss Smith's wonderful videos that go through pretty much the same material. There might be a problem here or there that's different, but overall it's pretty much the same thing. All right, have a wonderful day. Please work hard, do your best, and I will see you guys on Tuesday. Have a good one. Bye-bye.